All right, welcome to the Explainer. Today we're digging into a really clever technique that was one of the first ways we taught computers how to read. It's called TF IDF, and it's all about how we taught machines to look at a wall of text and figure out which words actually matter, to find that signal hidden in all the noise.
So let's start with the big problem. I mean, think about it. When you and I read a sentence, we just know which words are important. But a computer, it just sees a bunch of letters. So how do we teach it to tell the difference between the really meaningful words and, all the fluff? And that gets us to the first big hurdle in any kind of text analysis. Before a computer can do anything with language, every single word has to be turned into a number. I mean, you can't do math on the word apple, right? But you can do math on a number that stands in for apple. Okay, so let's walk through the first, most logical way people tried to solve this. It's a method called the bag of words model. And honestly, the name is pretty much exactly what it sounds like. The idea is super simple. Literally imagine you take a document, dump all its words into a big bag, and just shake it all up. Grammar, sentence structure, who cares? All of that gets tossed out. The only thing that matters is just counting how many times each word pops up, assuming that, hey, the most common words must be the most important. And this is where you can immediately see the problem, right? That whole idea just completely falls apart. It turns out the words you see the most often, words like the, is, and, are almost always the ones with the least meaning. The real signal, the good stuff like neural or quantum, just gets totally drowned out. Okay, so that's where this much smarter idea comes in. It's a technique called term frequency inverse document frequency, or TF-ID for short. And it just solves this whole problem so elegantly. Okay, so here's the big insight, the core idea. A word's true importance isn't just about how often you see it. It's all about a balance. A word is important if it shows up a lot in this one article you're reading, but it's pretty rare everywhere else. So let's break down how this actually works. TF-IDF, I mean, the name kind of gives it away. It breaks down into two main parts. First up, you've got term frequency, the TF part. You can think of this as the local counter. This is basically that bag of words idea we just talked about. It just counts how often a word shows up inside the one document you're looking at. It's all about local importance. All right, but the second half, this is the secret sauce. Inverse document frequency, or IDF. Think of this part like a really smart librarian who's read everything in the building. It's all about figuring out how unique or special a word is across all the documents. Super common words like the get a really low score, but rare specific words get a nice high score. And then you just put them together. It's that simple. You literally just multiply the two scores. So a word gets points for showing up a lot locally, but it gets penalized. Its score gets pushed right back down if it's too common everywhere else. It's this perfect little balancing act. Okay, check out this example. It makes it super clear. Let's say you've got 3 articles about AI. Words like machine and learning are in all of them. No big deal, right? So they get a low score for uniqueness. But then you have the word deep. It only shows up in one of those articles. Boom! That makes it rare, gives it a high score, and tells us it's probably a key concept for that specific document. Okay, so the logic is pretty straightforward and honestly, kind of brilliant. But where do you actually see this thing in action out in the real world? Well, it turns out it's foundational to a ton of things you probably use every day. It was a huge deal for early search engines and ranking web pages. It's used to figure out if an email is spam, or to automatically group together news articles that are all talking about the same thing. And the reason it's stuck around for so long, well, it's got some major advantages. I mean, it's simple. You can explain it to someone pretty easily. It's super fast, doesn't need a ton of computing power. And maybe best of all, you don't need some massive data set to train it. It just works right out of the box. Okay, but it's not a silver bullet, right? Nothing is. That simplicity has its limits. Because it ignores word order, dog bites man and man bites dog look exactly the same to it. And we all know those are very different headlines. It also has no idea what synonyms are. To TF-IDF, car and automobile or just two totally unrelated words.
So that kind of brings us to today. In this world of these giant, super complex AI models, is there still a place for something this simple? You bet there is. And this table really lays it all out. Sure, modern methods are way better at understanding context, but they're also way more complicated and expensive to run. For anything where you need an answer that's fast, cheap, and, this is a big one, easy to understand, TF IDF is still king. It's all about trade-offs. At the end of the day, TF IDF is just this perfect example of a bigger idea in technology. Sometimes the best tool for the job isn't the most complicated one. It's the one that's simple, reliable, and just plain gets the job done.
And that really leaves us with one final question to chew on. In this age of AI that can feel like a total black box, how much is a simple, elegant idea that we can all actually understand really worth? It's something to think about. Thanks for tuning in.